Hi, so in today's video I'm going to be looking at probability again, and this time we're going to be looking at listing outcomes. Okay, so we've got two different experiments that I've got going on here, and we're going to look at, in each situation, listing the outcomes and then using that list to calculate a probability. So if you need a quick recap on how to calculate simple probability, go back and check the video that I've already done on that, and then come back to this one. So we've got here, I've abbreviated it so I'll explain it as we go through. But in this first example, I've got two coins. So imagine I've got a 50p piece and a 20p piece, and I'm going to toss those two coins. And the first thing is we want to list all of those outcomes. Now, because we've just got two possible outcomes for a coin, which is heads or tails, it's quite simple, and we can list them. One way is really nice and straightforward. We can just list them by writing out the initials. So first of all, we could have coin 1 and coin 2. So you could list it as saying having the 50p and the 20p, and you could write out what happens on each one. So let's say we've got a head on the 50p and a tail on the 20, or you could get a head on the 50p and a head on the 20p. Or you could get a tail on the 50p and a tail on the 20p, or a tail on the 50p and a head on the 20p. And by doing it like that, you're actually covering all of the different options. So you're looking at the two scenarios where there's heads on the 50p piece, and then the different scenario for the 20p, and then you change it to tail and you do the same again there. And by doing that, you make sure that you cover all of the outcomes, and it is really important to think about writing these down in a logical way. You can actually then extend that to look at 3 coins and 4 coins, and that gives you some really quite interesting results as you start looking at more numbers of coins, but we'll keep it simple for today. Now, if you've only got 2 things happening, you can use something called a possibility space to list the outcomes as well, which actually makes it really nice and clear. So I'll show you that as well. So what we can do for this one, it's nice and straightforward. We can have the 50p piece on one side and the 20p piece on the other, and what you do is you just write out the different outcomes for those different things. So for the 50p, obviously you've got heads and tails, and for the 20p you've also got heads and tails. Now, what that then does is, inside the possibility space, and there are 2 options. Sometimes people just put little dots or crosses in here to represent the different things, or you can write them out. So here, this point here would be head, head, and this point here would be tail, head, and then this one here would be head, tail, and this one here would be tail, tail. Okay, so again, it's the same result, but just written in a slightly different way, and it's a different visual, and sometimes you might find it's a bit easier. So then from that, how do we actually answer the question? Now, what's really nice about possibility space is that once you've got that done, because of the fact that in this case there are 2 outcomes for each different thing, we've actually created a little square, if you notice, and it's a square of 2 by 2. 2 times 2 is 4, and if you notice there are 4 outcomes. So when we're calculating our probability, it's actually going to be out of 4, because there are 4 different possibilities. You can either get head head, head tail, tail head, or tail tail. And so any probability that we calculate is going to be out of 4. So again, going back to my previous video where I was talking about how to calculate probability, remember the denominator of the fraction is the number of different possible outcomes that there are. So in this case we have 4. So then let's look at this question. Find the probability of scoring the same on each coin. Okay, so on your possibility space or your list, whichever it is you've done, you find where you've got the same. So in this case you've got head head and tail tail. Okay. And then again, if you remember back to my previous video, the way of abbreviating it would be something like that. So you put the P to stand for probability, and in brackets you just put whatever abbreviation you want to use for the particular question. So I've just put same is equal to. Now here we found there are 2 different ways of getting the same score. And remember, out of a total of 4 different outcomes, so there's 2 out of 4. Now, just like with any work on fractions, if you can cancel it down, you should do. So then that is 1/2. Okay? Right, so moving on to my second example, example B. I've got a similar situation, but this time I've got spinners. You have to ignore the drawings, they're pretty terrible, but you kind of get the idea. So this spinner's got 3 sections and this spinner has got 5 sections. The idea being that the probability of any of the spinner landing on any of the 3 sections has to be the same. Everything has to be equally likely to get each of those numbers here and the same here. Alright, and that would be explained in the question, but obviously I've just abbreviated everything here. So the first thing we've got to do is list all the outcomes. Now, I would suggest that this kind of way of doing it for this question would be a bit more difficult, and actually this is where the possibility space becomes a lot easier. So I'm going to call my 2 spinners A and B just to make it easier, and I'm going to do it like this. So for spinner A, if we do that on the vertical side here, there are 3 outcomes and they are 1, 2 and 3. And for spinner B, here there are 5 outcomes, but if you notice the outcomes are 1, 1, 2, 2 and 3. So I'm going to write those on. 1, 1, 2, 2 and 3. Now depending on the question, sometimes you're just listing outcomes, other times they might say to you 2 spinners are spun and the total is worked out. In this case we're not doing that at all. It doesn't say anything about that. In fact, we're looking at the same question as here. What's the probability of getting the same score on each? So I'm going to do my listing again like this. So I'm going to put a comma because obviously we've got 2 numbers here, and if I wrote 1, 1 it would look like 11, so I'm going to put a comma between them. So 1, 1, 1, 1, 1, 2, 1, 2, 1, 3 and so on. Okay, so hopefully that's nice and easy for you to be able to do, and you can obviously write that down so it's clearer for you. And then that is all of the outcomes. Okay, now just like up here, how many different outcomes have we got altogether? Because that's important before we even start coming on to the probability. We've got to be able to work out how many outcomes there are altogether. So we have 3 along here, and as you remember rightly, I've got 5 along there. So altogether, I've actually got 15 different outcomes. So that there, for example, that is counted as 1 outcome. So overall, there are 15 possible outcomes. So any probability is going to be out of 15. Now, same thing again, probability of them being the same. We can go around and we can just circle them. So 1, 1, 1, 1, 2, 2, 2, 2, and there's a 3, 3. So altogether we've got 1, 2, 3, 4, 5. So probability of them being the same is 5 out of 15, and that looks like it cancels down as well. So what number goes into both 5 and 15? Well, it's 5. So the answer is a third. Okay. So if you write it out like this, it's a lot clearer, and then you should be able to easily calculate your probabilities.